In this video, we're going to apply integration by parts twice, using the formula that we've been using all the time. Integral a to b u dv is equal to uv, evaluated from a to b, minus integral a to b v du. The question is to evaluate integral from 1 to e log x squared dx. We're going to apply the Light principle. L stands for logs. In this case, that would be ln x squared. And a stands for algebraic functions. In this case, that would be 1. So we're going to write this as log x squared. This part is u. And 1 dx, this part is dv. All right, so what we have is we're going to let u be equal to log x squared. Its derivative, du, is going to be 2 log x, bringing the power down, and multiplied by the derivative of the inside using the chain rule. That's times 1 over x dx. dv is equal to 1 dx. Let's integrate both sides, and we get v. v is equal to x. Applying the formula, we have integral u dv, that's going to be log x squared times x from 1 to e, minus integral v du, that's going to be x, times du, that's 2 log x, times 1 over x dx. Let's label everything. So this part is u is log x squared, x is v, minus integral v, this part is x, v is x, and this part, all of this, is du. Now we can simplify this. The x cancels with the x. Let's rewrite this as log x squared times x from 1 to e, minus, bring 2 out, integral log x dx. And we won't forget the limits from 1 to e. All right, so now we have this integral to solve. Integral from 1 to e log x dx. And you can see how the power has been reduced. We had log x squared, now we have log x. So we know we're going in the right direction. We have to apply another integration by parts. So we're going to let u be equal to log x du is 1 over x dx. dv is dx. And integrate both sides. Integral of 1 dx is just x. v is equal to x. Let's put these in boxes. So we'll put this in a box and also put this thing in a box as well. All right. So now applying the formula, we have integral u dv. So that's going to be integral log x dx from 1 to e. That's going to be u times v. That's going to be x log x minus integral v, that's x, times du, that's 1 over x dx. X cancels out. We get x log x minus integral 1 dx is just x. So this part here is, let's label this as 2 stars and 2 stars here. So that's what we have. Now we just have to organize the answer. So basically what we have is integral from 1 to e log x squared dx is equal to x times log x squared, evaluated from 1 to e, minus 2 times x log x minus x, evaluated from 1 to e. Let's go back to the previous page and see how that works out. So just to show that, we have log x all squared times x from 1 to e minus 2 times the result we got when we integrate log x. That's going to be x log x minus x from 1 to e. All right, so now we can just write this all as one line. That would be a lot easier. So we can write this as x times log x squared minus 2x log x, distributing the minus 2, plus 2x. Let's check our algebra. So we have x times log x squared minus 2x log x plus 2x. All right, and that's evaluated from 1 to e. Now let's apply the fundamental theorem of calculus. Put the upper limit in. We get e times log e all squared minus 2e log e plus 2e minus, now put 1 in, we get 1 times log 1 all squared minus 2 times 1 log 1 plus 2. Log 1 is 0. Log 1 is 0 here. So log e is 1. Log e is 1. So what do we get? We get e times 1 minus 2e times 1 plus 2e minus 0 minus 0 plus 2. So 2e minus 2 is 0, and we just get e minus 2. This is the result of the integral. So the integral from 1 to e log x squared integrated by parts twice. This is a definite integral, and the result is e minus 2. Couple of notes, log of e is 1 and ln of 1 is 0. All right, let's look at another question that involves integration by parts twice. So here we have integral x squared sine of pi x dx. We're going to apply the Light principle. We'll choose u to be the function that comes first on the list. And clearly the algebraic function comes first. That means we should let u be equal to x squared. All right, so u is equal to x squared. Its derivative du is equal to 2x dx. dv is what is left over. dv will be sine of pi x dx. And if we anti-differentiate this using the reverse of the chain rule or the substitution technique, integral sine of pi x will be minus cos of pi x divided by pi. All right, so we're labeling this part x squared, this part is u, and this part here is dv. Sine of pi x dx, that's dv. And let's put this in a box. All right, so what we have is integral x squared sine pi x dx, u times v, that's going to be equal to u times v, that's x squared, times minus cos of pi x divided by pi, minus integral v minus cos of pi x divided by pi, that's v, times du, that's 2x dx. Let's simplify this a little bit. We get negative 1 over pi x squared cos of pi x, minus minus cancels out, that gives us a plus. The 2 is a constant, passes through the integral, so 2 over pi, the whole thing can come out. We get plus 2 over pi integral x cos of pi x dx. Now notice how we had x squared sine of pi x, and now we have x cos of pi x. So it has been reduced in power. The power x squared is now x. So we know we're going in the right direction. All right, so let's label this like this and solve this box here, and then we'll put it back into the result. So what we have is integral x cos of pi x dx. According to the Light principle, we're going to choose u to be the algebraic function because that comes first on the list. U is equal to x, and its derivative du, that's equal to dx. What is left over is dv. dv is equal to cos of pi x dx. And we integrate both sides, and the derivative of cos of pi x will be sine of pi x divided by pi, reversing the chain rule. Let's put this in a box. All right, so now we get u times v. That's going to be x times sine of pi x over pi uv minus integral v, which is sine of pi x over pi dx. All right, let's organize everything so we know what we're looking at. We have negative 1 over pi x squared cos of pi x plus 2 over pi integral of x cos of pi x dx. And we integrated this to get this result here. That's what we did on the last page. You can see how we did that in this step. All right, so it remains to integrate sine of pi x. So what we get is, let's write the result that we have from before, negative 1 over pi x squared cos of pi x. And doing a little bit of algebra, we get plus 2 over pi squared x sine of pi x minus 2 over pi squared integral sine of pi x dx. So all that remains is solving this integral. But we've solved this before. Integral sine of pi x is going to be minus cos of pi x divided by pi, reversing the chain rule. So that's minus cos of pi x divided by pi. The algebra is very important. It's so easy to make a mistake. So you really have to be careful with this. So minus 2 over pi squared multiplies all of this. And let's rewrite everything else that we had. Negative 1 over pi x squared cos of pi x plus 2x sine of pi x over pi squared minus 2 over pi cubed cos of pi x, and of course we should add a c. So let's just rewrite that. A bit more simplification would be great. Negative 1 over pi x squared cos of pi x plus 2x sine of pi x divided by pi squared. And we have two negatives, they cancel out, so we get plus 2 over pi cubed cos of pi x plus c. That is the answer. The answer to the integral. The integral being integral x squared sine of pi x dx. The answer to this integral is what we have above. All right, thanks.